We are on to part 2 of lesson 43. Lesson 43 is the regression line. We have been looking at scatter plots, and in our first 2 lessons, we sometimes would draw in a line to help see the direction of the relationship. And in this lesson, we are talking about what that line is and how you find it. So that line is called the regression line, and we use our calculators to find it. So we practiced that in last lesson. Now in this lesson, we are going to interpret our regression line, and the AP board is very picky about how they want you to interpret slope and y-intercept. So I have included those in our phrases to memorize down here. So I have the preferred method of writing the equation and defining the variables. And then down here I have the interpretation for y-intercept and the interpretation for slope. So let's go up here and we will start with y-intercept. So this is the letter A. And if you need to, you can write yourself a note like I did up here that that's the y-intercept. So I'm just going to try my best to follow this sentence frame. I'm only going to write about halfway. I'm only going to write to about there because our next step is going to be interpreting slope, and I'm going to need to write that over here. Okay, so we're going to follow this pretty closely. When the explanatory variable, so I usually use what is in the table or what is in the graph. If they have given us a graph, I prefer to use that than the table. So when the explanatory variable, so that is miles driven, when the miles driven is 0, so down here, and it says add in your units, but we already included that with miles driven with our explanatory variable, because our explanatory variable includes the unit. The unit is miles. So when the miles driven is 0, comma, our model predicts that the, and now we want response variable, so price, coming up here to the graph, price will be about, and then it says y-intercept with units. So the price will be about $38,257. So when the miles driven is 0, our model predicts that the price will be about $38,257. Let's think about in context what that means, because we're going to get some questions in the can you do. There's only 2 questions on the can you do that is going to ask, is our y-intercept meaningful? And in this case, our y-intercept, it describes a truck that is brand new, a truck that has not been driven at all. So essentially, our y-intercept is telling us the cost or the price of a brand new truck. Is that statistically meaningful? Yes, because there are cars with 0 miles. Well, in theory, there are cars with 0 miles driven. You guys will learn as you go to drive new test cars. Usually they have like 10 to 15 miles on them by the time you drive them, but that's because, you know, somebody's got to drive them onto the truck, off of the truck, around the dealership lot. But yes, this it is statistically meaningful. There are trucks that do have 0 miles driven on them, and those would be brand new trucks. So y-intercept tells us the value of our response variable when our x variable is 0. So it tells us the value of our response variable when our explanatory variable is 0. Now we're going to we're going to interpret slope. So I'm going to draw that like, boop, right there. And once again, I'm going to follow this phrases to memorize. So for every and then it says 1 unit increase. So 1 unit increase in the explanatory variable. So a 1 unit increase in miles driven would be 1 mile driven. So for every mile, or 1 mile driven, our model, and our model is the equation. Our model means our equation predicts price. So here it says response variable will, and now you guys decide based off of the value of our slope if it's going to increase or decrease. So hopefully you're talking to your screen and saying decrease. We can see, 1, that it's a negative relationship in the scatter plot, but 2, our slope is minus. It's negative. And that negative belongs to the slope. So for every 1 mile driven, our model predicts the price will decrease by about, and then it says put in the slope with the units. Slope with units. So our units for this is money. Our response variable is decreasing by money. So slope is 0.16, so we're going to say $0.16. And then let's talk about what that means. So for every 1 mile driven, our model predicts that price will decrease by about 16 cents. So that makes sense to me. Couple of things to note is you don't say negative 16 cents because this word decrease makes it so that you don't have to. So slope is negative here, which means that translates to a decrease here, and then you don't put the negative on your slope. So really, that's all we have for this part of the lesson for interpreting slope and y-intercept. The best feedback that I can give you on this is that you need to follow your sentence frames as closely as you can, and if you're a good memorizer, you're going to want to just memorize them. So there's obviously, this is not the only way to say these two things, but the AP board recommends that you choose a phrasing that you like, memorize it, and make sure that you are saying all the necessary things. So in this case, you need to make it clear that this means when the explanatory variable is 0, the response variable is, and then your y-intercept. And this needs to show that you know for every increase in x what y is doing. So you have one problem in this little quiz lesson down below where you are going to fill in the blanks for interpreting slope and y-intercept. So this one ended up being a shorter video. That's good.